In this problem, we're asked to calculate the work done on a skier as he moves down a hill by the normal force, gravity, and the force of friction. The main idea used in this problem is calculating work, where work is equal to the dot product between the force in question and the change in displacement. In all cases, the change in displacement will be equal to the length of the hill, which we've called d. So the dot product can be simplified to the magnitude of the force in question times the distance d times cosine of the angle between these two vectors. The normal force on the skier acts perpendicular to the slope, whereas delta r acts parallel to the slope. So the angle between these two vectors is 90 degrees. When we go to calculate the work done by the normal force, then we have the magnitude of the normal force times the length of the slope times cosine of this angle, 90 degrees. Cosine of 90 is equal to 0. Therefore, the work done on the skier by the normal force is equal to 0, which makes sense because the normal force is acting perpendicular to the direction of motion. To find the work done by gravity, we multiply the magnitude of the gravity force times the distance the skier goes down the slope times cosine theta, where theta is the angle between the gravity force and the displacement vector. In that case, it's this angle here. We now need to figure out what is theta equal to. Well, we know from trigonometry that the angle between the axis here and the gravity force is equal to alpha, where alpha is the incline of the slope. If this angle is alpha, and this angle here between this axis and the displacement vector is 90, the angle theta is therefore equal to 90 degrees minus alpha. Substituting in this expression into our formula for work, and then plugging in the numbers given in the problem statement, we can evaluate to find that the work done by gravity is equal to 207.9 kilojoules. We note that the work done by gravity is positive, and this makes sense because there is a component of the gravity force that is acting in the same direction as the motion. To find the work done by kinetic friction, we multiply the friction force by the length of the slope and the cosine of the angle between the friction force and the displacement vector. As can be seen in this diagram here, the friction force and the displacement are in opposite directions, so the angle between them is 180 degrees. Substituting in this value into our equation and substituting in the definition of kinetic friction, we can then simplify the cosine 180 degrees into a minus 1 and can substitute in the expression for the normal force found in part 1 into our equation. We then plug in the numbers given in the problem statement and evaluate to find that the work done by kinetic friction is negative 84 kilojoules. We then note that this work is negative, which makes sense because the friction force is acting in a direction opposite to the motion.